Hi everyone, for today's lesson we are going to learn about the 6 trigonometric ratios that we can use in order for us to find the lengths of right triangles. These 6 trigonometric ratios are going to be imperative for you to know, understand, and memorize for the unit circle test that will be taking place within the next week or so. Before we get started, I would like you to please go ahead and factor these 3 expressions. The first one is 9x squared minus 81. The second one is 5x squared minus 9x minus 2. And the third one is 27x cubed minus 81y cubed. Please pause the video and factor each expression individually. Then go ahead and restart the video and we will see how well you did. All right, for the first problem, you always want to look for a greatest common factor. And in this case, 9x squared and 81 both have in common a 9. So I'm going to factor out a 9, and my leftovers is going to be an x squared minus 9. From there, x squared minus 9 is a dot. It's a difference of 2 squares. So I'm going to break that apart into 2 more parentheses. So my final answer is going to be 9 times x plus 3 times x minus 3. Now, if you recognize that 9x squared minus 81 was a dots right away and you broke your answer apart into a 3x minus 9 times a 3x minus 9, you're not incorrect. You just didn't fully factor. So what you need to do is fully factor by identifying the GCF and factoring out the GCF of each parenthesis. 3x squared and 9 both have in common a 3. So our leftovers would be this would be 3x plus 9, 3x minus 9. So you'll have an x plus 3, and then I'll factor out a 3 right here, and we're going to have an x minus 3. The 3 times 3 is a 9, so I'm just multiplying the numbers on the outside, and we'll still end up with our final answer, our correct final answer. So that's what you do for the first one. For the second one, 5x squared minus 9x minus 2. All 3 of these terms do not have anything in common, so I'm just going to break it apart into 2 parentheses, splitting apart the 5x squared into a 5x and an x. My goal is to get a negative 9, and I'm going to work with the factors of 2, which are 2 and 1. So I'm just going to try a few things. My goal is to get a negative 9, so I'm going to multiply 5 times 2, and I get 10, and then 1x times 1, that'll give me 1x, and I know, or a 1. And a 10 and a 1 can get me a 9, and I want a negative 9. And I know that negative 10 plus 1 is equal to negative 9. So what that means is that I want to make 5 be multiplied by a negative 2. That'll give me a negative 10. Therefore, I'm going to be simply adding 1 on the inside. And I should end up with negative 9. 5 times negative 2 is negative 10, 1 times 1 is 1, negative 10 plus 1 is negative 9. So that is our factorization for number 2. For number 3, 27x cubed and 81y cubed both have in common, a 27. So I'm going to factor out a 27. And when I do that, I end up with x cubed minus an 81 divided by 27 is 3. So that's going to be a 3y cubed. Now, 3 is not a perfect cube. And so therefore, inside of a parentheses is not a difference of cubes. So there's nothing more for you to factor. This is simply your answer. It just had a GCF. So if you're still struggling with factoring, please make sure that you have a conversation with me. Factoring is not going away, and it will continue throughout the remainder of the quarter. So our learning targets for today is for you to be able to say, I can define the 6 trigonometric functions of an acute angle of a right triangle. And I can identify the trigonometric values, which this is very, very important for you to be able to identify the trigonometric values for your special angles of 30, 45, and 60. So we're going to be working with special right triangles of our 45, 45, 90, and 30, 60, 90 triangles that we learned about when we were in geometry class. We're going to learn, we're going to use those values to find the lengths of missing sides of a right triangle. So we have a lot of information that is going to be based on previous information that you've already learned. So we've already learned about sine, cosine, and tangent, but we actually have a total of 6 trigonometric ratios. The ratios of a right triangle's side lengths are used to define the trigonometric functions sine, cosine, and tangent But now we have cosecant, secant, and cotangent. So we actually are adding 3 more. So I want you to please make sure that you understand the relationship between sine, cosine, and tangent, and cosecant, secant, and cotangent. So we already know that sine is equal to opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite divided by adjacent. But what cosecant, secant, and cotangent are they are the reciprocal functions. They are the reciprocal functions, trigonometric functions, of sine, cosine, and tangent respectively. So cosecant of theta is the reciprocal of sine, 1 over the sine of theta. Or you can also look at it as the hypotenuse divided by the opposite. Secant of theta is the reciprocal of cosine. Or we can look at it as if it's the hypotenuse divided by the adjacent. Just write the reciprocal of our fraction. And cotangent is 1 over tangent. Or another way that we can view it is it's the adjacent divided by the opposite. So the way to remember which one goes with which is to remember that no 2 S's match and no 2 C's match. So remember that no 2 S's match, meaning that sine is not the reciprocal of secant, they don't match, and no 2 C's match. So that means that cosecant is not the reciprocal of cosine. So that's something for you to keep in mind. So it's C matches with S, and C matches with S. So that's what I want you to remember, is that sine matches with cosecant, cosine matches with secant. And then tangent and cotangent, they kind of are, they imply one another because they actually have the same exact number, or the same exact word involved in their name. So tangent and cotangent are reciprocals of one another. So what we want to do is we want to evaluate the 6 trigonometric functions of angle theta. So in angle theta, we have ourselves our hypotenuse. Across from angle theta, we have 8 is the opposite and 15 is the adjacent. So what we need to do is we need to identify what the hypotenuse is. So I'm going to be working with the Pythagorean theorem in order to help me to identify my hypotenuse. I'm going to call the hypotenuse C, and I'm going to write 8 squared plus 15 squared is equal to C squared. 8 squared, that is equal to 64, plus 15 squared, that is equal to 225, and that's supposed to equal C squared. 64 plus 225, that's equal to 289, is equal to C squared. I'm going to take the square root of both sides, and we find that C is equal to 17. So C is equal to 17, and we're going to use that 17 in order for us to identify what the sine of theta is, the cosine of theta, the tangent of theta. So the sine of theta, that's equal to the opposite over the hypotenuse. So that's going to be equal to 8 over 17. The cosine of theta, that's equal to the adjacent over the hypotenuse. So that's 15 divided by 17. And the tangent of theta, that's equal to the opposite over the adjacent. So that's going to be 8 over 15. So now I'm going to identify my other trigonometric ratios that are going to be reciprocals. So the reciprocal of sine is cosecant. So the cosecant, CSC of theta, that's going to be equal to 17 over 8. The secant of theta, that's going to be equal to 17 over 15. That's the reciprocal of cosine. And the reciprocal of tangent is cotangent. So the cotangent of theta is equal to 15 divided by 8. So if you're ever asked to evaluate the 6 trigonometric functions of an angle, they're not asking you to find the angle, they're simply asking you to identify the ratio. So let's go ahead and look at example number 2. It says if theta is an acute angle of a right triangle, and we're told that the cosine of theta is equal to 3/8, what is the value of the cotangent of theta? So the first thing that we need to do is we need to figure out what all of the lengths of our sides of our triangle are. So I'm going to go ahead and draw my right triangle, and I'm going to call this angle right here theta. And cosine, that is equal to the adjacent divided by the hypotenuse. So because that's the adjacent divided by the hypotenuse, I know that the adjacent is going to be 3 and my hypotenuse is going to be 8. But we know that cotangent is the reciprocal of tangent, and tangent is equal to opposite over adjacent. So I need to identify what my opposite side is. So in order for me to identify what my opposite side is, which I'm just going to call that little a, I'm going to use the Pythagorean theorem. So that's going to be 3 squared plus a squared is equal to 8 squared. So 3 squared, that's equal to 9. So 9 plus a squared is equal to 64. I'm going to subtract 9 on both sides, and I end up with a squared is equal to 55. Now I'm going to take the square root of both sides, and when I do that, I end up with a is equal to, well, 55 is just 5 times 11, so we can't break that down. So I'm just going to leave it as the square root of 55. Always leave your answers as in simplified radical form. And simplified radical form in this case is simply the square root of 55. Now, if I could break that down, then I absolutely would. If there did exist a perfect square factor, then I would break down my square root into something where I have a number outside of a square root. So I'm going to use this value to identify what the cotangent of theta is. If you want, work with tangent first. We know that the tangent of theta is going to be equal to the opposite, which the opposite is the square root of 55, divided by the adjacent, which is 3. But we know that cotangent is the reciprocal. So that's going to be 3 over the square root of 55. But we have ourselves a root in our bottom. You're not allowed to have a root in your bottom. So the way to get rid of that is to multiply the top and the bottom by that root. And when you do that, you're going to end up with 3 square roots of 55 divided by 55, and that is your answer. So that kind of goes back to chapter 6, where we learned about our square root rules. If you need to go back and check out your notes for that or review the book, that might be something to consider. Let's go ahead and look at example number 3. In example number 3, once again, we're working with another right triangle. It says, if theta is an acute angle of a right triangle, and we're told that the cosecant of theta is equal to 7/10, find the value of the sine of theta. So I'm going to write theta, and my cosecant, that is going to be, that's the reciprocal of sine. So I actually don't even need to draw a triangle in this case. If I want to, I could, but this is equal to, I take that back. I think this is supposed to be cosine now that I'm looking at it, guys, because you can't have 7/10 as a cosecant, because cosecant is equal to the hypotenuse over the opposite. So I'm sorry, we're going to change that to cosine right here. So I apologize for that. Change that to the cosine of theta, and we want to find what the sine of theta is. So I'm going to put in cosine, that's going to be 7/10, and we need to find what the sine of theta is, which is the opposite over the hypotenuse. So that means that I need to find what my opposite side is. So I'm going to use the Pythagorean theorem, and I'm going to write 7 squared plus a squared is equal to 10 squared. So I have 49 plus a squared is equal to 100. I'm going to divide both sides by 49. And when I do that, subtract 49 on both sides, and when I do that, I end up with a squared is equal to 51. And I'm going to take the square root of both sides, and I end up with a is equal to simply the square root of 51. 51 does not have any perfect square factors, but if it did, we would break it down even further. So now I'm going to identify what the sine of theta is. Sine of theta is going to be equal to the opposite, which is the square root of 51, divided by the hypotenuse. And we're simply going to leave our answer as the sine of theta is equal to the square root of 51 over 10. And that is our answer. Let's go ahead and move on to the next page. This page is very, very important. I'm going to put 100 million stars, or at least 4 stars, around this space. And that's because we're going to be, these values that you're going to be filling out on the table are going to be crucial for you to know in order for you to get through the unit circle test. So I need you to make sure that you pay attention very closely to what I'm going to talk about. It says the trigonometric values for special angles. Now, our special angles come from our special right triangles. We have a 30, 60, 90 triangle, and we have 45, 45, 90 triangles. Those are our 2 special right triangles that what this table is going to be based off. It says the table below gives the values of the 6 trigonometric functions for the angles of 30 degrees, 45 degrees, and 60 degrees. You can obtain these values from the triangles that are shown. Please make flashcards of these values and start memorizing them for your unit circle. You will need to know them for your unit circle. So I cannot emphasize that enough. Your goal is going to be to look for patterns in this table. And there are several patterns that exist in this table that you're going to see very shortly. So look for patterns in this table. All right, let's go ahead and start with 30 degrees. So what I have down here is a 30, 60, 90 triangle. And I'm going to zoom in on this 30, 60, 90 triangle. And what makes this a 30, 60, 90 triangle is the fact that we have the degrees not only drawn in there, but we have the measures. If we were to call the short side, which the short side is always across from the 30-degree angle, the short side is always our focus. Short side is going to be called 1, or the length of 1, and that's going to become very important whenever we create our unit circle, because the radius is going to be 1. So whatever your focus side is, it's going to be like the short side was our focus side. That's going to represent our radius. The long side is always across from the 60-degree angle, and our hypotenuse is always across from our biggest angle, which is a right angle in this case. And in order to go from the short leg to the long leg, we multiply the short leg by the square root of 3. And in order to go from the short leg to the hypotenuse, we multiply the short leg by 2. And so that's how we were able to come up with these values, just based on our patterns that we learned last year in geometry. So what I'm going to do is I'm going to identify what the sine of 30 degrees is, the cosine of 30 degrees, and the tangent of 30 degrees. And then I'm going to work with their inverses. So the sine of 30 degrees, that is going to be the opposite, which in this case, this is the opposite, divided by the hypotenuse. So that's 1 over 2. So that's our sine. The sine of 30 degrees is 1/2. That's how we read this. Sine of 30 degrees is 1/2. Let's go ahead and identify the cosine of 30 degrees. Cosine of 30 degrees, that's the adjacent over the hypotenuse. So that's the square root of 3 over 2. So the cosine of 30 degrees is square root of 3 over 2. Let's look at the tangent of 30 degrees. The tangent of 30 degrees is the opposite divided by the adjacent. So my opposite is 1 and my adjacent is the square root of 3. So I'm going to write 1 over the square root of 3. But you're not allowed to have a root in your bottom, so we have to multiply the top and the bottom by the square root of 3. So our answer for the tangent of theta is the square root of 3 over 3. Or the tangent of 30 degrees is the square root of 3 over 3. Now cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent respectively. So the reciprocal of 1 over 2 is 2 over 1. 2 over 1 is equal to 2. The secant of 30 degrees, that's going to be the reciprocal of the square root of 3 over 2, and that's 2 over the square root of 3. So if I were to get rid of the root in my bottom by multiplying the top and the bottom by the square root of 3, the secant of 30 degrees is 2 square roots of 3 over 3. The cotangent is the reciprocal of tangent. So that's going to be 3 over the square root of 3. And I have to get rid of the root in my bottom by multiplying the top and the bottom by the square root of 3. So I end up with 3 square roots of 3 over 3. The 3's will cancel out, and I'm left with the square root of 3. So the cotangent of 30 degrees is the square root of 3. Let's go ahead and look at the 60-degree angle before I talk about 45. This way we're just working with the same triangle. So now my focus angle is on the 60-degree angle. The short side is now the adjacent side, and the long side is now the opposite. So we want to identify what the sine of 60 degrees is. And the sine of 60 degrees, that's going to be the opposite over the hypotenuse. So that's going to be the square root of 3 over 2. Look at that. The cosine of 30 degrees is equivalent to the sine of 60 degrees. Just putting that out there. I want to encourage you to look for patterns. So now let's find the cosine of 60 degrees. So the cosine of 60 degrees, well, that's going to be equal to the adjacent over the hypotenuse, and that is 1/2, 1/2. The tangent of 60 degrees, that's going to be equal to the opposite over the adjacent. And the opposite over the adjacent, that's going to be the square root of 3 over 1. And so that is going to be equal to the square root of 3. So far we've worked with similar values. The square root of 3 appeared when we were looking at the cotangent of 30 degrees. So there's like some reciprocal relationships taking place here. So now let's go ahead and look at cosecant. The cosecant of theta, it's going to be the reciprocal of sine. So that's going to be 2 over the square root of 3. And we know that that 2 over the square root of 3, we've already simplified that to 2 square roots of 3 over 3. The secant of theta, that's the reciprocal of 1/2, and we've already wrote down the reciprocal of 1/2 as 2. And if we were to write the reciprocal of tangent, that's 1 over the square root of 3, and we've already simplified that as the square root of 3 over 3. So between 30 degrees and 60 degrees, you have a lot of opposite or reciprocal relationships taking place. Please go ahead and look for those patterns and start memorizing those relationships right away. Now let's go ahead and look at 45 degrees. Now 45, 45, 90 triangles is an isosceles triangle, which means that it has 2 side lengths that are equivalent to one another. And so whenever we were learning about our special right triangles, we know that everything was based on the leg. So in order to go from your leg to the hypotenuse, you multiply your leg by the square root of 2. So if we know that our leg, which is our focus, is 1, then our hypotenuse will be the square root of 2. So I'm going to make my angle of 45 my focus, and I want to find the sine. So the sine is the opposite over the hypotenuse. So the opposite over the hypotenuse, that's going to be 1 over the square root of 2. So I need to multiply the top and the bottom by the square root of 2 in order to get rid of the root in the bottom, and I end up with the square root of 2 over 2. The cosine of theta, so the cosine of 45 degrees, is the adjacent over the hypotenuse, which is once again 1 over the square root of 2. And we know that's going to simplify to the square root of 2 over 2. Notice that 45, 45, 90 triangles, we have the angles that are equivalent to one another. And notice that the sine and cosine are equivalent to one another when it comes to 45 degrees. For the tangent, that's going to be opposite over the adjacent, and that's 1 over 1, which is 1. So now let's go ahead and look at the cosecant. So the cosecant of theta, instead of me going back and doing all of that work of rewriting the reciprocal, what I'm going to do is go back to the original. What is the reciprocal of 1 over the square root of 2? That's going to be the square root of 2 over 1, which is simply the square root of 2. If I were to look at the secant of theta, the secant of 45 degrees, once again, that's the reciprocal of 1 over the square root of 2, which is once again the square root of 2 over 1, which is the square root of 2. So both of these are equivalent to one another. So it's kind of equal, it's kind of easier to memorize the 45 degree angle one. And then we have cotangent, and the reciprocal of 1 is 1. So these two are actually equal to one another. So like I said, there's so many different patterns for you guys to look for and to understand and to study. And all of our unit circle is going to be based on these triangles. So that is something that I want you guys to keep in mind as we go through our lessons all the way through 3.3 when we finally create a unit circle. 2 more examples and then we are finished. It says, find the value of x and y in this triangle shown. What we want to use, I don't know what it says using, so in the triangle shown, please do not use your special right triangle rules that you used from geometry. You can kind of use SOHCAHTOA, but I don't want you to use SOHCAHTOA in the traditional sense that we've already learned. Instead, I want you to work with our values from the table. So what I mean by that is this. If I wanted to find what x is, I'm going to make my focus angle 30 degrees. And so since my focus angle is 30 degrees and I want to find what x is the opposite, and I know my adjacent. So opposite and adjacent requires us to work with tangent. So I'm going to write the tangent of 30 degrees is equal to x over 8. Instead of doing cross product at this step, instead what I would like you to do is I want you to replace the tangent of 30 with the value that we have in the table. The tangent of 30 is the square root of 3 over 3. So I'm going to replace the tangent of 30 with the square root of 3 over 3. And now I'm going to set that equal to x over 8. So from here I'm going to use cross product. And I end up with 8 times the square root of 3 is equal to 3x. I'm going to divide both sides by 3, and we find our answer to be 8 square roots of 3 over 3. And that is our exact answer. I know that you worked with the table of values when you give me an answer that is not a decimal. I do not want a decimal answer, I want an exact answer. And the best way to get an exact answer is to use your patterns that we have up here. Next, we want to find what y is. So I know that y is the hypotenuse, and I know the adjacent is 8. So adjacent and hypotenuse would mean that we're working with cosine. So I'm going to write the cosine of 30 degrees. That's equal to the adjacent, which is 8, divided by the hypotenuse, which is y. Instead of doing cross product right away, I'm going to work with the cosine of theta, cosine of 30 degrees, and that is the square root of 3 over 2. So I'm going to write the square root of 3 over 2. That's going to be equal to 8 over y. I'm going to write the cross product. And I end up with the square root of 3 times y is equal to 16. I'm going to divide both sides by the square root of 3. And I now end up with y is equal to 16 over the square root of 3. I can't have a root in my bottom, so I'm going to multiply the top and the bottom by the square root of 3. And so therefore y is equal to 16 square roots of 3 over 3. You could have made 60 degrees your focus angle. That would not have been a big deal. You still would have ended up with x and y equaling the exact same thing. So now I'm going to go ahead and look at number 5. This time around we have a 45, 45, 90 triangle. And in this case, 6 is the hypotenuse, and we want to find the adjacent side with respect to the 45. So adjacent and hypotenuse is cosine. So I'm going to write the cosine of 45. That's equal to the adjacent, which is x, divided by the hypotenuse, which is 6. Instead of going with cross product right away, I would like you to please change this cosine of 45 degrees to square root of 2 over 2. So I'm going to write the square root of 2 over 2 is equal to x over 6. And we're going to use cross product, and we end up with 6 square roots of 2 is equal to 2x. I'm going to divide both sides by 2, and we find that x is equal to 3 square roots of 2 if I were to simplify the 6 over 2. And that is simply our answer. There is nothing further for you to show, and that is the end of this lesson. If you have any questions over anything, please make sure that you email me. We will certainly talk about this next time I see you. Otherwise, I hope you have a wonderful day.